All right, we're back. We're on page 4 of notes 15. We are doing integrals with trig substitutions, not an AP calculus topic, but a really cool topic. And I like for my students to know it because I feel like it gives them the ability to integrate things that they otherwise wouldn't. All right, let's dive in. So these all look like they're going to be worse than the previous page. They all seem to have like higher degree things. So we'll see how that goes. But whatever, same idea. Draw a triangle. Come on. Oh, look at that, saved it. All right, so this has to be the hypotenuse because of the plus. So I'm gonna put my 2x here and 3 here. And then, so I'm gonna say that x, so that the tangent of x would be, no, tangent of theta would be 2x over 3. So x is 3/2 tan theta. And then we need dx is going to be 3/2 secant squared. And then the radical, you want to choose the ratio that involves the radical, but not the other side that has x. So 3 secant. Also, there's just like a lot of secants involved at this point. So like that kind of helps you figure out like what to use. All right, let's make our substitutions. There's 3 things. This is going here. And then this is going here. And then this is going here. And we're raising it to the 4th. Ugh. So what you don't want to do is you don't want to start like expanding things. You don't want to make it like 81 over 16 because there's going to be some canceling. So like let the canceling happen, right? So I'm going to say that this integral becomes dx. So 3/2. I'm just going to, no, actually I'm going to leave it in. 3/2 secant squared of theta d theta. Nope, that was just, what am I even doing? Oh yeah, that's my dx. I'm gonna move that because I was supposed to do the radical first and I forgot. The radical is 3 secant. Come on. I was gonna write 3 cant, I guess. Like I was gonna combine the 3 and the secant. So this, I have made a mess of this so far. So this is this, and then let's just highlight so that, you know, when in doubt, just highlight it out, you know. 3/2 tan theta. Be great if I would stop putting parentheses around things, but I can't make myself do it. Okay, so what do we have here? We have 3 squared over 2 from the numerator. So we got 3 squared over 2. The denominator, we have 3 to the 4th, 2 to the 4th, but it's in the denominator. So we really have 2 to the 4th, 3 to the 4th. And then we have secant cubed over tan to the 4th. Holy cow, something good gonna happen here? Secant cubed over tangent to the 4th. I'm thinking I'm going all sines and cosines because I don't really know what to do there. So this will be 2, so what cancels? Let's just get the coefficient right. Like, let's guarantee that. So we get 2 cubed is 8 over 3 squared, which is 9. And then here, all right, I got, okay, so this is sine over cosine. So it's sine to the 4th over cosine to the 4th, but it really like pulls the cosine to the 4th to the numerator and then over that. So I think I have cosine over sine to the 4th. I believe all of that simplifies to cosine over sine to the 4th. I think. Where do I have some space to write that? So what I did was 1 over cosine cubed over sine to the 4th over cosine to the 4th, which is cosine to the 4th over cosine cubed sine to the 4th, which gave me cosine over sine to the 4th. And that is pretty much a perfect thing, right? So that's, if I made u equal sine, then du would be cosine d theta. So it's actually just u to the -4th, which is negative plus 1 times the reciprocal. So negative 1/3. Okay. So negative 8/9 times negative 1/3 is negative 8 27ths, and then I get sine to the negative third. Is this notation correct? I think so. That's gross. I don't like using that exponent there. What is sine? Sine is, how could there not be a radical in this answer? There's no chance. Oh wait, there is. Oh my God, I just got sine wrong again. I thought sine was this over this. Sine is this over this. This seems very conceivable. So I'm gonna put sine is 2x over the radical. So this will be negative 8 over 27, then 2x over the radical, and the radical was radical 4x squared plus 9. I might split this page because this is a lot. Negative third. So this has like a little bit of weird simplifying you can do, because 2 to the negative third is 1/8, and that'll cancel with that. So now I think I'm getting negative 1 over 27 times, I'm going to say it's 4x squared plus 9 to the 3/2 over x cubed plus c plus c. Whew, I'm checking that one now. I don't know, because if there's a mistake, we have to like wade in and try to find it. So let's see. Integral square root of 4x squared plus 9 over x to the 4th. This is like a real moment of truth. What is this? Is this like the same thing, just like weird? Like x squared? Oh God, did they expand? All right, hold on. They did like algebra on this thing. Hey, 1 over 27. Because what we have, what we have is 4x squared plus 9 to the 3/2. That factors, which is annoying, right? You can make it the quantity 4x squared plus 9 times radical. I think that's what they've done. And then I think they like, I don't know, other stuff. X cubed. I don't know, expand? Let's take the derivative of that. Common denominator. Okay, so I took the derivative of our answer, I got a common denominator, and it's the same. So we got calculator give a weird answer that as it's entitled to, and as it is as it often does. So we got that. All right, I'm gonna do one more in this video, and then I'll break it up because these are long. Are they hard? Yeah, I mean, they're not easy, that's for sure. There's no radical. Also, this looks like I should complete the square, so I'm just gonna do that. Out of the gates, we're completing the square. Dx, but we're gonna like cheap complete the square. So I'm gonna break this up. Like x squared minus 6x, there should be a plus 9, so I'm gonna make 11 plus 9 plus 2. X squared minus 6x plus 9 plus 2. It's like a advanced sort of, it's not cheating, but like that's the advanced scheming for completing the squares. Notice a constant that you can break up. Now we got x minus 3 squared plus 2 squared. But there's no radical. So what do? We put in a radical. This is a crazy problem. So x minus 3 squared plus 2. And then I got to raise that to the 4th. Those are equivalent. Like if you start simplifying from this to this to this to this, so they're the same. All right, triangle. It's gonna be a weird triangle though, because this is radical 2 squared, so that's great. Here we go. Draw. Of all the things that I don't need going wrong for me, it's drawing a triangle. So this will be radical x minus 3 squared plus radical 2 squared. So I'm going to put x minus 3 here, and I'm going to put radical 2 here. And we're going to be really careful with the details and not make any mistakes. So we'll see how this goes. Okay, so x minus 3 is equal to radical 2 tangent of theta, which means that dx is radical 2 secant squared of theta d theta. It's like there's nothing different about the setup. It's just that it's all gross. Secant of theta. So secant is the radical over radical 2. So I'm just going to bring radical 2 across. What's this? Whew. There's a lot. It's a lot, but I think we got this. All right, what substitutions are we making? We are going to make, so this is going to be this, and then we have to raise it to the 4th power. Luckily, there's not like a random x hanging around, and this is this. Okay, let's do this. So we'll get the integral of dx is going to be radical 2 secant squared of theta d theta. Am I going to have to do cosine squared? I think I am. Cosine squared, man, shows up everywhere. So I get radical 2 to the 4th is 2 squared, so it's actually just 4. And then I get secant to the 4th. So I get radical 2 over 4, the integral of 1 over secant squared is cosine squared. Power reducing, so we're going to reduce this. So there's a radical 2 over 4, and then cosine squared is 1 plus cosine of 2 theta over 2. So I'm going to take out a 1/2 again. And then I get 1 plus cosine of 2 theta. So I tried to show, I don't know, I tried to show more steps than I ordinarily would. So we get radical 2 over 8. I have theta, and then plus 1/2 sine of 2 theta plus c. Oh my god, I was about to make that a definite integral. Whew, can you imagine? All right, so I'm going to say that theta is the inverse tangent of x minus 3 over radical 2, which, like, the calculator, if it is definitely going to either not do or rationalize or something. So we'll find out that. And then, all right, so sine of 2 theta is 2 sine theta cosine theta. So the 2 and the 1/2 cancel. So we're back to just radical 2 over 8. And then sine times cosine. So sine is this over this, and cosine is, wait, sine is this over everyone. I think I've forgotten how sine and cosine work, or specifically sine. Sine is this over this. Cosine is this over this. So what? So I guess I get radical 2 times x minus 3 over, holy cow. So I think I get radical 2 x minus 3. So that obviously simplifies to like 1/4. The radical 2 times radical 2 is 2, and then 2 over 8 is 4, 1/4. And then I have to square this. But squaring this takes, squaring, if I expand this stuff, I just end up, you know, here to here to here. And then, so it's radical this, and then if I square it, I just get x squared minus 6x plus 11, I think. Okay, so I think I just get x squared minus 6x plus 11. I would listen to arguments that that is wrong if somebody wanted to make them. So I think that we get radical 2 over 8 tan inverse x minus 3 over radical 2 plus 1/4 x minus 3 over x squared minus 6x plus 11. It's hard to believe that that could be right, but maybe it is. So let's see. All right, so I'm gonna ask the calculator to find the antiderivative, but like I have little faith that it will look like what we got, but who knows? Integral, I was gonna do differential equation solver, which actually you could solve it, just call it y prime, but you know, non-traditional. Squared, let's see how wrong-ish this looks. Oh wait, no, that's exactly what we got. It just rationalized the radical 2. Wow, all right, woo, look at us, killing it. All right, That's enough for one video, right? So I will stop this here. I'm gonna go back to the notes so you can see them. Also, am I gonna be losing my voice for the rest of this school year? Maybe. I hope not. There we go. So we have 2 answers here. Let's highlight them. And then maybe the other ones will be equally challenging, or at least equally interesting. Or maybe they'll be way, way harder. Who knows? I don't really like this this x cubed that I'm seeing here. That looks dangerous. All right, I'll be back in the next video and we're gonna do problem 7 and 8. So I will see you there.